like to look at this graph, and we have two different graphs on here. We have the g of x, which is in red, and we have f of x, which is in blue. And what we want to talk about is those function operations. So we're still talking about function operations. And with those function operations, here we do not have the actual equations. So here we actually have to look at the graphs. And with function operations of the graphs, you have to pay attention to x, y values, things of that nature. So when we look at, let's say, if I want g minus f at, we'll go with -5. Okay? No, -5 won't work. Let's go at 0. G minus f at 0. What that's going to tell us to do is find g at 0 and then subtract f at 0. So when we're looking at this, we first go to where g is 0. Remember, this is my x value. So I go to where x is 0, so right here, and I look where it hits my g function, which is the red function. So at g of 0, my y value is actually 0. And then I'm going to subtract where f is 0, so I'm still on this x-axis. I'm sorry, the y-axis, x being 0. And I go to where it hits my f function, and that y value is 6. So 0 minus 6 is going to be a -6. So I'm taking this value minus this value. If I were to try to find g minus f at 2, I would go over to 2 and find where it hit my g function, which is 12. And then I would subtract where it hits my f function at 2, which is 3. And I would get 9. So whenever you're having function operations, you're looking at where am I hitting my graph at those particular x values. Now let's look at some other operations, not just subtraction. So let's look at maybe a division operation. So let's think about if I do f divided by g at -3. Okay? So that means I'm going to take f at -3, and then I'm going to divide it by g at -3. So I'm going to come over here to x being -3. So I'm going to basically kind of draw a dashed line here at -3. So I'm going to find where it hits my f function, the blue function, which is at 3. And then I'm going to find where it hits my g function, which is here at 7. And so f divided by g at -3 would be 3/7. The ones that tend to be a little bit more difficult are composition of functions, just like we found earlier, were the composition of functions, okay? And so let's look at a composition of functions after I erase these numbers here. Let's look at if I have g of f we'll say at 4. Okay, at positive 4. Remember that this is g of f at 4. So what I'm going to do first is I'm actually going to find f at 4. And I'm going to find that number first. So you always go from, remember, the inside here. So you're going to find f at 4 first. So at 4, f is 0. Then I'm not finding g at 4. I'm actually finding g at 0, whatever that y value was. So I'm going to go to g, and at 0, g is actually at 0. So this is my solution. So wherever you have those compositions, you need to find the second function at that given number first. Then, whatever your solution is, find the first function at that given solution. Let's look at another one. Let's look at f of g at -3. So I'm going to first find g at -3. Because I'm always going to do the interior one first. So g at -3, I'm going to come over to -3, and I'm going to find where it touches g, and that is at 7. So this is at 7. And then I will find f at 7. So I come over to a positive 7 and follow it to where it hits f, which is at 6. So f of g at -3 is actually 6. So when you're doing the composition of functions, again, you find that interior one first, find its solution, and then find the exterior at the solution of that interior. So be careful with those, do some practice, and then let me know if you have questions.